chapter's name. So in modeling, we have software requirements, then software requirements specification, then your UML and DFD. Okay, so there are 4 topics under your chapter number, this chapter, modeling chapter. So modeling has software requirements, next software requirements specification, which is SRS, UML and DFD. So the software, these are some theory part. Just let us just go through once so that we can understand. So this is, one second. The software requirements or requirement engineering. Okay, so requirement engineering is nothing but just to gather, just to collect all the information before we normally document it. Okay, before we document it, we have to collect all the information, all the resources from the client, and then finally analyze the requirements, then document them. That is known as requirement engineering. So why do we perform requirement engineering is that in order to develop and maintain a descriptive document. Okay, in order to maintain sophisticated and descriptive document. So that document is known as SRS, which we have done in our last class. Okay, so that is software requirement specification. So once again, let me tell you. So requirement engineering is nothing but we have to collect all the requirements, all the informations from our client so that we can analyze the requirements, resources, and then finally we can document them. This process for documenting the requirements, it is known as requirement engineering. Now, here the goal of requirement engineering. What is the goal of requirement engineering? Why do we perform requirement engineering? So requirement engineering is performed in order to get a documentation, descriptive documentation, which is known as SRS, System Requirement Specification, or we call it sometimes Software Requirement Specification. So we have some processes here. Let us see the processes. The process are feasibility study. So feasibility study. So we need a thorough study of the requirements we have collected, requirements gathering, software requirement specification, and software requirement validation. So when it is asked to you what are the requirement engineering process, you have to answer this 4. So there are 4 steps in requirement engineering process: feasibility study, requirement gathering, software requirement specification. So this section, this part is done in our last class, software requirement specification. Okay. Then software requirement validation. So there must be a validation process after we finish making our documentation. Okay. Now feasibility study, in this feasibility study, normally it is focused on the goal of the organization. Okay, in the goal. So what is our purpose? What is the purpose for requirement gathering? So that it is focused on the goal of the organization, and also we can practically we can materialize in terms of implementation, contribution of the project to organization, cost constraints, and other certain objectives of the software. Okay, so here by doing the feasibility study. That means before we initially start collecting the information, gathering the information, we need to understand first what is the goal of the organization, what are we going to do, which type of software we are going to develop, and in terms of implementation, what do we require, then how, what will be the cost of this development process. All these things we need to study before we initially start gathering the information. Okay, that is feasibility study. So the output of the feasibility study will be number of comments will be there, number of recommendations will be there, whether to what to do, what not to do, that will be there. Okay, feasibility study, once again I'm telling you, it is focus on the goal of the organization, and here we are going to study what kinds of software it will be we are going to develop, and in implementation purposes, what do we require in implementation, what is the cost constraints of this software developing process, and what are the objectives of the organization. All this we need to study initially before we start requirement gathering. So that process is known as feasibility study. And in requirement gathering, after understanding all these factors, we need to start collecting the requirements from the user or from the client. Okay, so in order to collect requirements from the user or from the client, some analysts and some engineers are required, because they need to communicate with the client so that they can know the ideas of the client. Okay, what does the user wants? So what kind of requirements do they want, and what kind of software do they want to develop? So that has to be communicated by some members of analysts and engineers. Okay, so requirement gathering is where we are going to start gathering the requirements from the users, and there will be some members of analysts and engineers who will communicate with the client or who will communicate with the user, so that we can understand what are the ideas do the users have, and are what kind of software do the users want to develop. That in order to understand that, we need members of analysts and engineers in requirement gathering. So for software requirement specification, as I told you in our last class, it is a document. We are going to create a document by system analyst after the requirements are being collected from the users or from any kind of various stakeholders. So SRS is nothing but a document. Okay. So in SRS there will be like interaction. You can see the interaction between the software and the hardware. There will be external interfaces, the speed of operation, what is the cost constraints, what is the execution time, response time of the system, and like all this uh, process will be defined in our SRS. Okay, so what do we require? What are the requirements? What is the software requirements? What is the hardware requirements? And what kind of interfaces we have? Then what is the speed of operation? Then time, how much time it consumes? The response time of the systems. When a user gives some input, what is the response time we get from the system? Like this. Then maintainability and quality of the software or the document. So, and we will be studying the certain limitations of our software. One second, some people are joining now. So all those things will be discussed in our software requirement specification. Okay. So it looks like a complete document, where we have all the necessary details of the software. That is software requirement specification. So I have given you some examples also. Anyway, we will discuss once again. So SRS, normally it will have the following features. The first feature is all types of user requirements will be explained or will be expressed in natural language. So English here, normally we follow English as our natural language. So we will be using proper language to explain the requirements or to express the user requirements. And also the technical requirements can be explained in terms of structured language. This is inside the organization. So certain organizations, they have certain protocols, like they can use some kind of language, they can use type of some kind of graphical representation to explain the technical requirements. So like that, certain organizations, they have different way of expressing their technical requirements. So they can use any structured language to explain the technical requirements. And this design description, they should be written in pseudocode, and there will be some screen GUI, screen prints, conditional mathematical notations can be there. Like normally, as I told you in our last class also, when you write a thesis, there will be mathematical notations, there will be flow charts, there will be data flow diagrams, there will be many types of equations and all. There will be graphical diagrams, there will be block diagrams, like this. There will be architecture diagrams, like that. So similarly in SRS also, it is a complete document where we explain our user requirements in a complete manner, which shows your this one: external interfaces, hardware requirements, software requirements, time constraints, and quality, limitations, security, everything. So everything has to be explained in a SRS document. So in validation part, where we are going to check certain conditions here. The first condition is if they can be practically implemented. So whatever the requirements we need, we have written in our document. Okay, we have written the graphical representation also, we have written the mathematical operations, mathematical notations, diagrams, everything we have written in our SRS document. Now we are going to check if they can be practically implemented, whether you can truly implement your uh, program, you can truly implement your software. That has to be checked. That becomes one essential condition in checking the validation, software requirement validation. So here, every requirements we use in the SRS document should be validated. Okay, so that is why we have these following conditions. Initially, we are going to check if they can be practically implemented, and secondly, we are going to check if they are valid and as per functionality and domain of software. So like uh, whatever the documents you have collected, whether it is like if the documents are valid based on the domain of the software. So there may be some requirements of the software we are going to develop, and we are going to check if they match. So there may be say for software requirements, we have collected these other requirements. Again, on the other hand, we have our domain of the software. So for this particular software we are going to develop, we may have certain requirements. So we are going to check if they are matched or if they are truly valid as per the domain of software. And also we are going to check if there are any redundancies or any ambiguities, similarities. So repeated requirements or redundant requirements are not entertained. So we are going to check if they have any kind of software redundancy, requirement redundancies. And next condition is if they are complete, whether the software requirements you have collected, you have gathered are fully complete, that we are going to check. And finally we are going to check if they can be demonstrated. So these are some software the requirement validation um, conditions to be checked before after constructing our SRS document. So when I say requirement engineering process, what are the requirement engineering process? We have to explain about the feasibility study. We have to explain about requirement gathering. We have to explain about requirement software requirement specification, and we have to explain about software requirement validation. And on the other hand, we also have requirement elicitation process. Okay, requirement elicitation process. So this is another step for requirement software requirements. So in this requirement elicitation process, we have requirement gathering, we have requirement organization, we have negotiation, we have requirement specification. So just go through the notes which I have given. Here also requirement gathering remains the same. You are going to collect information from client, and organizing requirements is nothing but arranging the requirements. Negotiation and discussion is nothing but if you have repeated or redundant data, redundant requirements, then there can be conflicts in requirements of various stakeholders. So we need to discuss with the stakeholders that this kind of requirements are ambiguous, like that, and which requirements should be given the first priority if they are redundant. So like that, or whether the requirement has to be removed from the collection. So that has to be negotiated and also should be discussed in this negotiation and discussion process. And finally, documentation is nothing but making your SRS document where it contains all kinds of formal, informal, functional, non-functional requirements. So we will see what is formal requirements, informal requirements, functional and non-functional requirements. So here, requirement elicitation process, again we have 4 steps. Now for the first requirement engineering process, we have 4 steps. Now another one is there, requirement elicitation techniques. Okay, requirement elicitation techniques. We have certain techniques for requirement elicitation. We will discuss that one. Elicitation is like some kind of uh, selecting only the relevant requirements or discovering only the uh, relevant requirements. So we will see requirement elicitation is the process to find out requirements for an intended software system by communicating with client and users, system users, and others who have a stake in the software system development. So we will see to this one to discover requirements. We have interviews. So this interview is one kind of technique for requirement elicitation. So in interview, what are we normally uh, perform in our interview? What do we do in an interview? So in an interview, normally there will be some questionnaire section, or there will be some interviewer, and the persons who attend the interview, there will be some questionnaire sections where the interviewer will ask some questions and the other person will answer for it. And we are going to validate whether this person is fit for the uh, company or organization or like that. So similar to that, meaning we have interviews as one technique in requirement elicitation in order to find out the requirements, in order to discover which kind of requirement we are going to select. So here in interviews, initially we have 1, 2, 3, 4, 5, 6 types of interviews. Okay, first one is structured or closed interviews, where every single information to gather is decided in advance. They follow pattern and matter of discussion firmly. So here, structured or closed interview is nothing but every information you are going to collect or you are going to gather is already decided in advance by a team of experts. Okay, they are already decided in advance. So this type of requirements only you have to select like that. And non-structured interviews are also called open interviews is where information to gather is not decided in advance. That means the software requirement or requirement gatherings process is not decided in advance, and there can be certain techniques which we can select the requirements. So this is open interviews. Closed interviews, already the information are known and it is already known in advance. And here in open interviews, the information are not known in advance, so it has to be collected, it has to be studied, like we perform some feasibility study, then we have to collect the information. Now, oral interviews, you know, right? So like person to person orally conducting interview. So, team of experts can interview a user and he can directly ask to the user which kind of software you want to develop and what kind of requirements, what are the requirements you want to include. He can ask directly, person to person. And written interviews, you already know. So written interviews, it means he has to write the requirements. The user has to write the requirements. And one-to-one interviews which are held between two persons across the table. So in oral interviews, person to person, but can be through phone and can be through any medium. Now in one-to-one interview, it means directly person to person across the table. Okay, across the table, the team of experts can ask to the user what kind of requirements is necessary. Like the group interviews, so where there will be multiple groups of participants or users where the expert people can get their ideas from the group of people. That is group interviews. Like this, we have surveys also. Surveys is nothing but historical data. When I say surveys, it's nothing but historical data. That means we are going to collect the information based on our historical requirements. That means based on our observed data. Okay, based on our observed data which we already have. So from that, we are going to collect some necessary information. That thing is known as surveys. And questionnaires, that means we will be asking a set of questions where the user can give some options or can give some answers. So a document with predefined set of objective questions. Okay, so some set of questions will be there, and from that you have to give some respective options, and you can hand over this questionnaire to the analyst or the engineer or team of expert people. And task analysis is also analyzing the operation, analyzing what kind of operation we will be performing. And domain analysis, this is also same. There will be some expert people in the domain. They are going to analyze the requirements. So brainstorming is a kind of informal debate. Okay, an informal debate is held among various stakeholders and their inputs are recorded. So an informal debate will be held and their inputs, their ideas, we can record it for further requirement analysis. So like this, you go through all the steps. So these steps which I have just told now is under requirement elicitation techniques. We have interviews, we have surveys, we have questionnaires, we have task analysis, we have domain analysis, we have brainstorming, we have prototyping. Prototyping is nothing but there will be some functionality added for the user in order to get better idea of requirements. Okay, in order to get better idea from the user, we will be adding a user interface. Okay, one functionality will be added to the for the user. So this is done usually with the client, and also by getting feedback from the client. That means by getting feedback from the users. So this feedback from the users will be serving as an input for requirement gathering. So that is prototyping. And observation, a team of experts will observe the organizations or the workplace, the client's organization or the workplace, and they will observe the actual working of the existing installed system. And if they need to update the system, they can update it, they can check the workflow, they can check everything what is going on with the existing system, and finally they can draw some conclusion so that we can form a new updated requirements for the software. So that is done under observation. So this steps comes under requirement elicitation techniques. So like this, we'll go to the other one also. So some characteristics are there for software characteristics. So they should have a clear, correct, consistent, modifiable, verifiable, prioritized, unambiguous, traceable, credible sources. So these are all the specifications which SRS document must include. Okay. And as I told you, in that SRS document, we need to include functional requirements, non-functional requirements. So that is explained here. What is functional requirement? That is the requirements which are related to any functional aspects of the software. Okay, any functional aspects. That means they should define the functions and functionality within and from the software system. So examples are also given here for your understanding purpose. You can just give search option given to the user to search from various invoices, like this. So some functionality, this is directly given so that the user can interact with the system. So that kind of requirement is known as functional requirements. Whereas in non-functional requirements, these are the requirements which are not related with the functional aspects of software, okay, which are not related with the functional aspects, but in which the users can be assumed, okay, which like say this may include security, logging, storage, configuration, performance. So this one, we do not need to directly interact with the system, okay, providing security, providing logging purposes, storage purposes, configuration, performance, cost, interoperability. These are the non-functional requirements as we do not directly interact with the system. Okay. That is why it is said here, these are not related to functional aspects of software. Whereas in functional requirements, you can just see it is related to the functional aspect of software, like there will be direct interaction with the system. Searching option given to user, which means a user has to interact with the system, right? And user should be able to mail any report to the management. So this is also like a user is interacting with the system management or any management people who are responsible for developing the software. And also users can be divided into groups, and groups can have separate rights. So that means if there are any problems, the user can directly complain to the management. So like this, these are functional requirements which are related to functional aspects, whereas in non-functional, it is not related to the functional aspects. That means we do not need to directly interact with the system. user interface requirements. These are very easy to, one second, some are still joining. So user interface requirements must have this following this criteria. It must be easy to operate, it must be quick in response, it must be effectively handling operational errors, it must be supporting,
Excuse me, ma'am.
and also,
Ma'am, Soumya
yes,
Anand is trying to enter the class from last 15 minutes.
sorry,
Ma'am, Soumya Anand, she's trying to enter the class from last 20 minutes.
I haven't received any notification.
Okay, ma'am. Okay, I
You,
will tell
you
her.
asked to join again.
Okay, ma'am.
So like this, let's not go deeper into these theories. I think theories everyone can read by yourself, and it is an easy English. You can understand just by reading it. So let me go through other this one, other topics. So user interface, the main characteristics are these four characteristics, and also in software metrics and measurements. So we will have separate chapter for this software metrics and measures. So there is difference between metrics and measure. So measurement, as you know, measurement means what? Measure, measuring. What is the measure? What is the measure? What is the measure? Can you give any example of measure? So this full topic we will be discussing in a separate chapter, but just going through what is a measure. Metric I will say, but measurement you can say, right? What is a measure? Measurement means what? Measurement. Do you really don't know what is measurement?
Ma'am, dimension of a
Ma'am.
particular thing. Dimension of a particular thing.
I'm measuring something, right? In
Yes, ma'am.
terms of length, you can measure. In terms of uh, kilograms, you can measure. In terms of volume, you can measure. Like this, that is called measurement, right? So
Yes, ma'am.
that is measurement. Okay. So measurement means nothing but we can quantify, we can, so how much volume, how much capacity, how much length, how much weight, like that. We are going to perform some measurement. But in metric, we are going to perform, we are going to, this is a kind of measurement here also, but not in terms of all those volume capacity. Say for example, if I say LOC is nothing but lines of code. So how many lines of code are there in our software, this development process? So when we say that is called size metrics, size metrics, which is measured in terms of LOC. LOC is nothing but lines of code. Okay. But when you write, when we use the unit for this, we will be using the unit as KLOC. K is nothing but kilo. Kilo lines of code. Just like in measurement, we say kilograms, 500 kilograms, 600 kgs. Like this, we used to say, no. Similarly, if you're in software metrics also, we will be saying kilo lines of code. So this much kilo lines of codes we use in our software development process, like that. So software metrics and measures. So that we will be discussing in the next, not next chapter, maybe next to next chapter. So like that, we have certain metrics. This is size metrics. Complexity metrics is also there, where we are going to measure the cyclometric complexity. We are going to measure the quality metrics like defects, number of defects, how many number of defects are there in the whole process, that will be measured. And also we have process metrics here, methods and tools used. Okay, how many methods, which methods we have used, which tool we have used, and what is the performance of the particular method we use. That will be discussed in process metrics and resource metrics finally. Resource metrics, we are going to measure effort, time, especially time, how much time and how much effort we have. Time development, it is called time development, it is called effort. So resource metrics will be under another chapter. That means calculating effort and time. Some lots of calculations will be there in the upcoming chapters. But for now, yes, we will go through this theories. Okay, so this is about your software requirements, requirement engineering, what are the elicitation process, what are those quality software requirement process, user interface, functional and non-functional requirements. So this all comes under requirement engineering. Okay, so now same we have design, software design also. In software design, we will be having architectural design, we will be having high level design, and we also have detailed design. So three types of software designs are there. One is architectural design, which explains the whole version of the system through diagram. Okay, that is architectural design. And high level design, high level design is like you will be having multiple components. So the single system, we can divide it into sub modules, subsystems, and we can have certain number of components. So that is high level design. And in final one, we have detailed design. Detailed design is we have where it deals with the implementation part. So detailed design will deal about the implementation part. Okay. So and it also defines in design, detailed design, every module and interfaces to communicate with other modules. Okay, that has to be discussed in. Okay, anyway, once again, let me show you the say software design. So software design is a process to transform user requirements into suitable form, which helps the programmer in software coding and implementation. So what we have done earlier was only the requirement gathering part. Requirement gathering, how we are going to collect the requirements. So through various techniques we have seen for requirement gathering. So once we finish the requirement gathering, we have our next step as design, software design. So this is converting all our requirements into a form which a programmer can understand and which he can use in software coding and implementation. So for that, we have three levels of design. We have architectural design, which I have just explained. It is the abstract version of the overall system, and high level design, it will have multiple components, and detailed design, it will deal about the implementation part, and also it defines each module and their interface to be communicated with other modules. So that is detailed design. So this is also theories you can also go through. So here modularization, here it is a technique to divide the software system into multiple and independent modules. Okay, so we must be having certain modules, sub-modules. We are breaking down our complete system into sub-modules so that each module can work out, each module should be capable of performing their own tasks independently. Why do we divide our overall system into sub-modules? So that we can easily finish our tasks earlier, and also If a person is doing a work by single-handed, it may take long time. So we are just dividing our work into we're assigning our work into different persons so that each person can do their own work, complete it, finish it, and finally integrate it and finish the job. So the same concept we are doing in modularization. Here also we are going to divide our complete system, our complete software system into multiple modules, okay, independent modules. So each module will perform their own work and finally it will integrate and will give you a final result. So that is what it is explained here, and some advantages are written down here. You just go through. Then concurrency, an example, coupling and cohesion. These are also all comes under software designs. So in concurrency also, there will be like splitting the software into multiple units of execution. Just like we are dividing into different modules, they are also into different units of execution and also executing them in parallel. So that is here, you can see this step. Concurrency provides capability to the software to execute more than one part of code in parallel to each other. Okay, so each unit of execution will be executed in parallel. So since we divide our whole system into different modules, so each module has to be executed independently. That is, its modules has to be executed in parallel. So every module will have a section of program code. Every module will have a section of program code. This program code will be executed in parallel. So that is the property of concurrency. And coupling and cohesion is also like you can see here, coupling and cohesion is also a measure that defines the degree of interdependability. So how much there is interdependability within elements of a module. So in the module we have some elements, so that we are going to check how much interdependability. That means the elements are depending on each other. So what is the degree that we have to check? You can see here we have 7 types of cohesion: coincidental, logical, temporal. So these are not much important. We are not going through whole this one. But for your understanding purpose, you can just go through the notes. Okay, what is cohesion? You need to understand what is cohesion. That's all. Cohesion is nothing but it is a measure that defines the degree of interdependability within elements of a module. Like that, what is coupling? Coupling is a measure that defines the level of interdependability among the modules of the program. So in intra, it means within a particular thing, okay, within a particular module. Here in coupling, what does it mean? It is interdependability. That means within different modules. Since our whole system is divided into multiple modules, so each module, separate modules, what is the interdependability? One module depending on the other module. So module 1, module 2, module 3 up to module 5 if we have. So we are going to check if module 1 is dependent on module 2 and if module 2 is dependent on module 3 and if module 3 dependent on module 4, or if 1 is dependent on 4, the 2 is dependent on 5, like that. We are going to check among the modules, but in cohesion, we are going to check within a module itself. So since we divided into multiple modules, every module will have certain elements inside it. Okay, So that elements interdependability we are going to check. So once again, in cohesion, what do we need to check? Interdependability within elements of a module. While in coupling, we are going to check interdependability among modules of a program. Okay. So then verification at the end. So verification, we have after finishing your design phase, we need to perform a verification, design verification. So design verification in order to check if the design which you have constructed or which you have met all the requirements, or if it is can be implemented, whether the design which you have constructed can be implemented or not. So we have to do a verification process after you complete your design phase. Now this is data flow diagrams. Okay. So what we have seen today, we have seen about the requirement engineering, and we have seen certain steps how we actually need to gather the information and what are the techniques we have seen. And today also we have seen what is a design, software design, how many types of software designs are there, and what are the certain properties of software design, and what is software metrics, what is software measures, that also we have seen, and calculations for software metrics, software measures, those metrics calculation we will do in the upcoming chapters. And before that, just like data for UML diagram, we also can present our data into using data flow diagram. So data flow diagram is a graphical representation of flow of data. So within the information system, how the data is uh, sending from one section to one module to the other module, all those flow of data will be explained using a graphical representation, just like your UML diagram. But how we draw the diagram is a little different. Here we explain the flow of data. Okay. Flow of data, what is the incoming data flow, what is the outgoing data flow, and what are the stored data. That has to be explained in a data flow diagram. So there is a difference between data flow and flow chart. Flow chart depicts the flow of control. So there will be flow of control in the program module, and DFD's data flow diagrams depict flow of data in a system at various levels. Okay. So data flow diagram does not contain any control or any branch elements. Whereas in flow chart, you can have your condition statement, you can have branches, you can have any controls. But in DFD, you do not have any control or branch elements. It just explains the flow of data in the system. So components, these are the notations. This is entity or class or object. Entity is represented as an object. Process. So any process which you are going to perform will be put in this symbol, and data store symbol is this one. Data flow symbol is using these arrows. So entities, it is explained here. I told you it is an object. So entities are source and destination. So source and destination of information of data, from where it is initiated, from where it's going to end. So that will be shown in entity process. Data storage here. So what the database will be represented using this symbol. So we can store our data using this symbol. We can put data flow symbol, just this one. Okay, so we are going to use only these four symbols for drawing the data flow diagrams. Unlike UML diagram, we have many symbols in order to draw the UML diagram. But for data flow diagram, we are going to use these four symbols in particular. And for Drawing the DFT diagram, there will be level 0, level 1 and level 2. So level 0 is the highest abstraction level and it depicts the entire information system in one diagram. Okay, in a single diagram, it explains the entire information system. While in level 1, it's going to explain more specific about the information system. Okay, there will be basic modules, there will be data flow, there will be sources of information will be explained in level 1. In level 0, what does it say? It says it explains only the information system in one diagram. You can see here, online shopping system. This is the customers. This is online shopping system. Customers is going to give order through this portal and the online shopping system, the authority or the people inside who are responsible, they will collect our order and they will send our order to us. So here in one diagram, we can understand the customer is ordering something through the online shopping system and the particular product which you have ordered is getting delivered to the customer. So this kind of representation is known as level 0. Level 0 DFD diagram, data flow diagram. So this rectangular symbol is known as the entity symbol. So this is the source, this is the destination. Source entity, destination entity, and it can be end to end. It can be source, it can be entity also. But what do we do? This customer should be the source because initially the customer has to give order to the online shopping system. So one diagram, we understand the user is ordering something and getting something to this portal. Okay, so this explains about the level 0 DFT diagram. Whereas the same diagram we can explain into a detailed diagram. It can be more specific like this. So we have accounts, we have order processing, we have sales. So this is the customer. So the customer is ordering through the sales portal and the sales entity what's going to do, process the order from the customer. The customer is given order here. So the sales entity is going to process the order and it's going to verify the customer data who is giving the order. And once you finish your verification purpose, payment process will be done here. If the payment is confirmed, then we have a store, our product store. From this product store, we will get the item and the item will be sent to the sales. Then the sales will deliver to the customer. So like this, the same concept here, we are representing in a detailed manner. Okay, this is known as level 1 DFD diagram. Level 1 DFD diagram. This explains more specific about the system. Okay, so here even you can see very easily you can understand online shopping system customers. So customers ordering something, getting our product. So this result also we can easily understand that this is a online shopping system. And if we go through this diagram also, you can understand that the customer is ordering something through a online shopping system and getting the item delivered to the customer, but in a detailed manner. How? We have sales as one entity here, where the customer will order through the sales and some processing will be done here. What kind of processing? Like verification processing for the customer data and also payment verification through the account entity. And also this order processing is responsible to get the order from the store and the store people will issue the item. So this all processing is this processing has responsible with this things, with the customer data to verify the data of the customer, and payment process verification, and also getting the item from the store. And finally, once you get the order from the store, then this order has to be delivered to the customer. So a detailed information is shown here rather than this one. So this is the basic information. That's why we call level 0. A detailed information, that's why we call level 1. And in level 2, also there will be more modules, more detailed information than this one, more detailed information than level 1. So that diagrams we will see in next example. Okay. So DFD, and also we can represent using charts, structured charts. So charts are drawn in this one. For charts, we will explain in next class how to draw the charts, data flow. It is also somewhat similar than Hippo diagram. So how Hippo diagram is nothing but hierarchical input processing output diagram. This also is there for representing in graphical structure. We will explain these two diagrams in our next class. So how many diagrams we have in our this modeling? We have UML diagrams, we have DFD diagrams, we have structure charts, and we have Hippo diagram. So Hippo is hierarchical input and input process and output diagram. So these diagrams explanation we will do in our next class. So let me just show you one example, and we will wind up for today's class. So DFD, which we have discussed now, DFD, the diagram, let me show you one example. So for train reservation, here it is shown train reservation process. This is passenger, this is admin. We have 3 steps here, okay? Passenger, through the reservation process, all those ticket reservation cancellation will be done here, and through admin. So we have only these steps for explaining our train reservation. So 0 level, this is the basic information. So 0 level DFT. While in level 1, we have another reservation process as well as ticket generation process, and also giving report to admin as one process, and inquiry also one process. So passenger has certain types of process to be done. So here only reservation process is shown here. Here how many processes are shown? From reservation we have ticket generation process, we have report to admin, we have inquiry. So this does not says that you must draw same diagram like what I have shown here. You have to understand the concept and you can draw diagrams accordingly. Okay. So we will explain some, we will study some more examples. So for 2 level DFD, more detailed diagram. So more detailed diagram. Here it is shown. Okay. So I think I don't know whether I have sent the materials for DFD diagram or not. Some other DFD diagram. 1 second. Let me just check. Okay, so like in UML, there are certain ways. If I say use case, many types of use case diagrams are there. If I say class diagram, many types of class diagram are there. So similarly in DFT diagram of diagram also we have certain types of representations of the diagram. Okay. So that diagrams we will see in our next class. Okay. Just 1 second. See, this one is also one zero level diagram for hospital management. Okay, hospital management system. The process is here, and these are the certain entities we have. Okay, doctor management is one entity, for login one entity, for user management one entity, for patient management one entity, for employees one entity we have, for hospital management like this. This is the whole process, and these are the certain entities associated with the hospital management process. Okay, so this is zero level diagram. So like this also you can draw the zero level diagram, the basic information, and that is the basic information. And 1 second. For first level DFT diagram for the hospital management, it can also be drawn like this. Okay, so like this it can also be drawn. So here you have the hospital management process, then you have certain entities associated with it. For hospital management, patient medicine, test management, login, user management, then generating hospital reports like this. This shows more detailed information about the hospital management. So this can be first level DFT diagram. And lastly, one more, and with this. So this is second level DFD. The second level DFD, here many processes are there. For the admin log into the system, then check the credentials. Once admin check the credentials, and if the credentials are correct, then he can check roles of access. That means what are the operations he can do, so he can manage the modules. What kind of modules that has been associated with this manage system like this. There are certain modules he can manage, and in case if when he logins, if he forgot the password, he can send email to the user. So this shows more details about hospital management than level 1. So like this. So level by level, if you increase, it shows detailed information. Level 0, basic information. Next level 1, detailed information. But in level 2, a more detailed information than level 1. Like this. Okay. So like this also you can draw second level diagram. So there are certain ways to draw the DFT diagrams. You can follow any steps or any process to follow the diagram. So more examples we will do in our next class. Now it is already time. Let us finish our class for today. We will study remaining diagrams and explanations tomorrow. For diagram explanations tomorrow. Okay. So answer your roll call. Roll number 1.
Present, ma'am.
Roll number 2.
Present, ma'am.
Roll number 3. 3 hasn't joined the class. Okay.